Morning guys, today we are back with another problem, and today's problem is finding the length of the loop. So what is today's problem? Today's finding is finding the length of the loop. It's an easy problem. What it is saying that we will be given a head of the linked list. Determine whether the list contains a loop. If the loop is present, return the number of nodes in the loop, or else return 0. Okay, so this is a problem of DSA, which is a very common problem, and it is asked in many of the companies like Accenture, Infosys, and many other such companies. So what you can see is initially there's a loop which is starting from 2 and it is ending at 5. So 1, 2, 3, 4, 1, 2, 3, 4. The length of the loop in this case is 4. Similarly, if you take an example of this particular linked list, 25, 14, 19, 33, 10, 21, 39, 90, 58, 45, C equals to 4. That means it is starting from 1, 2, 3, 4th position over here, and the loop is running. So now we have to check the length of the loop. So the loop is running till 45. So the loop is running till 45. So what is the length of the loop? The length of the loop is 1, 2, 3, 4, 5, 6, 7. So the answer is 7. Okay, so this is the problem statement, and how we are going to solve this we are going to discuss right now. Okay, so our first task is to find out the loop detection in the linked list. So I can see we have to loop detection in linked list. Okay, loop detection in linked list. So for loop detection in linked list, I can say I can make a function, I can make this function as int detect. Okay, I can make this function as int detect. I will be having a node head. Okay, once I have detected the loop, I am going to check the base cases whether my header is null, or my next element of the head is null. So I will be checking head is equals to null, or my head dot next is equals to null. So in this case, I'm going to return a 0. Okay, after that I will be having a slow and fast pointers. So I can say node slow equals to head. Similarly, I can say node fast equals to head. Okay, once this part is done, what I can do is I can use loop detection algorithm. So I can use Floyd's loop detection algorithm. Okay, so in the Floyd's loop detection algorithm, what I will be doing is I'll be having a while loop. Okay, where my fast is not equals to null. Okay, and my fast dot next not equals to null. Okay, so in this case, what I'll be doing is I'll be moving ahead. So I can say slow dot next. Okay, and fast, since it's a fast pointer, it will move fast dot next. Okay, so at any point of time, how will I detect whether it is a loop or not? So I'll put a condition if my slow value is equals to fast value. Okay, so in this case, I'm going to return the count function, count the number of elements. Okay, count the length of the loop. So I can say count slow as the length of the loop. Okay, or after this, I'll be returning 0 as the count if the length is 0. Now this is the function I have made for the length of the function. But how will I make the length of the function? So I can say a function, say count L. So in this function, I will be passing, say, a node root. Okay, first my base condition need to be checked. So before that, I am going to initialize a count equals to 1 as my initial counter. Okay, so I will be storing this root value in a current node. So I can say node current equals to root. Okay, once this is done, I will be traversing through the binary, I will be traversing through the linked list. So for that, I will have a condition that this value is not null. Okay, so if this is not null, what I can do is my current equals to current dot next, and I can increase the counter plus, and once the loop is done, I can return this counter. Okay, so let us start and try to solve this particular set of problem. Okay, finding the length of the loop. So this is this function. First, before that, I'm going to make the count function. So how I'm going to make a count function? I can say a count method. So int count. Okay, and I can pass a node root. I will check a counter equals to 1, and I will store it in a current node. Current equals to root, while my current dot next not equals to the root value. So if my current dot next is not the root value, I can continue with the looping process and find the length. So current equals to current dot next C++, return C. Okay, and over here I have to develop the logic. So before that I have to check the base cases. If head equals to null, or head dot next equals to null, then return 0. Okay, after that I have to initialize slow equals to head, node fast equals to head. Okay, once slow and fast pointers are made, I can traverse through the link using Floyd algorithm, using Floyd loop detection algo. So in the loop detection, what I'll be writing is fast not equals to null. Okay, first case, and fast dot next is also not equals to null. Okay, in both the cases, so I will write slow equals to slow dot next, which will move on slow speed. It will skip pointers, so fast will skip pointers, so I will write fast dot next dot next. Okay, once that is done, I'll be using null detect. So if slow is equals to fast at any point, what I'll be doing is I'll be returning the count. So I can call the function count, and I can pass the pointer slow in my case. Okay, or I can return 0. Now let's compile. Yeah, this is working. So let us submit. Number of nodes. I've written to count the number of nodes, and over here I can write slow pointer, and I can write fast pointer skipping elements, and I can write base cases. So current node till it is not equal to my root value. So yeah, that was the problem statement. Guys, make sure you guys like, share and subscribe to the channel, and thank you so much. We are looking forward to see you in our next video.